Okay, welcome Year 12s to another episode of Math in the Bubble with your host, Mr. Daly. Um, we're going to call this episode 7, even though yes, on Wednesday I said I was starting a new season. I sort of decided that was going to be too confusing for everyone who just watches the videos. So today I'm going to introduce to you guys this general circle formula. So there's two things that might stick out, is this XC and this YC. So those parts, XC and YC, those are the coordinates for the center of the circle. Right. So and then x squared is just, this just helps you find the coordinates for x. If you're given a y, you can work back your way to it. R squared, this is the radius squared. Yeah, so first off, I'm just going to show you how a very simple one would work. So one formula for a circle might look like this: x minus 3 squared plus y minus 5 squared equals 2 squared. So it's not always written 2 squared, you might just have it written as 4, but basically the radius of our circle is going to be 2. So that number there is going to be our x coordinate of the center of the circle, and that is going to be our y coordinate of the center of the circle. So 3 along the x, there's 3, and 5 will give us the center of our circle there at 3, 5, and our radius of our circle is 2. So we get points around there, and you can just draw it in like that. And that's almost all you need to know about circles. And you can, what's worth doing maybe once or twice is finding a point on the circle. So you'll notice that you get, if we put in x equals 4, then we'd actually get 2 points on the circle. We get one there, and we get one there. And that's because our answer is going to end up as a quadratic for y or x, regarding to what we're putting in. Let's just do that to figure out what those two y coordinates would be. So x equals 4. So that's going to give us 4 minus 3 squared plus y minus 5 squared equals 4. Alright, this is just going to be 1. 4 minus 3 is 1. 1 squared is 1. And we can expand this out. We're going to get y squared. Our middle term is going to be minus 10y. And then we're going to have plus 25. And that equals 4. So this is just a quadratic which hasn't been simplified, and then we're using y's instead of x's. So we can use the quadratic formula almost. We just need to set everything equal to 0. So to do that, we need to add our numbers together. So we need to get this 4 over to the other side and so we're going to have 1 and 25 is 26. Minus 4 will give us y equals 26 minus 4 is 22, so positive 22 equals 0. Now we've got our equation in a quadratic form. Our a is going to be 1, because there's an invisible 1 there. Our b is going to be negative 10, and our c is going to be 22. So if we put that into our quadratic formula, we're going to get minus b, which is negative 10, plus or minus the square root of b squared minus 4 times a times c. So minus 10, this is just, and then all over 2 times a. So these are our y values that we're going to get. So we're going to get y equals 10. I've just cancelled out those two negatives. A negative and a negative just cancels each other out. 10 plus or minus, we're going to have 100 minus 4 times 22 is 88. So in here we got the square root of 12. And then that's all divided by 2. So that'll give us our two answers. Y equals, I'll just put that into my calculator now. Oops. It's good to put a bracket around this first bit so that I only need to write it out once and change the plus. I've got that on my, I don't want to cover anything up. There we go. Square root 12. Whoops. And that's divided by 2. So one answer is 6.732. So if we think to our thing, that would be this value here, 6.732. And if we change our plus to a minus in our quadratic formula, whoops, no, where's the delete button? Delete. It's going to be 3.267. 3.267. Yeah. So to find any coordinate on a circle, then unless it's really simple numbers, you're probably going to have to use the quadratic formula. So that's probably a pretty typical question for when you're doing the NCA test, but I don't think you have to do much of that in the graphs assignment. That's a bit advanced, but a lot of things in year 12 come back to the quadratic formula. So just if you ever see squareds, there's generally a way to use the quadratic formula to find your answer. I might just draw one more circle on here. So a good simple thing to think about is this formula is basically Pythagoras. So this is a squared plus b squared equals c squared. But instead it's with x's and y's. So one way to think of it is a simple example would be x squared plus y squared equals 10 squared, or 100. So this is a perfect triangle one solution that works is 6 squared plus 8 squared equals 10 squared. So when x equals 6, y equals 8. So that's the solution that works. So we can plot that on there. And actually this works for negative 6 and positive 8. So there'll be a solution across the way over here. Is that coming up on there? Oops, I didn't get that quite right. So that's it. X equals negative 6, y equals positive 8. And then we could also change the 8 could be a negative 8. So we're going to get another set of points down here. And here. And actually these numbers could be swapped around. We could have x is the 8 and y is the 6. So x is 8, y is 6. And that'll happen all the way around the circle. And you can see that this is basically this is the triangle here. That should be up there. So that is 8 by 6, this triangle. Damn. Almost made that perfect. So we get all these points around the circle. If we connect them all up, and we get a big circle. If you think about here, that's when x is 0, y is negative 10, that point down there, equals 10 squared. So yeah, 6 and 8 and oops. So interesting that this formula for a circle is essentially an extension of the Pythagoras formula, a squared plus b squared equals c squared. It's the same sort of form, really. Yeah. I might just color that triangle in. That's 6 by 8, and then our radius is 10. This is a 3. I could have done a 3, 4, 5 triangle, but I wanted to do it nice and big. I just doubled it. All right. That probably confused the living daylights out of you. So we'll abandon it and move on to cubics, and then I'll just get you guys to suggest some problems. And yeah. All right. So cubics in. Just need this. So you guys will be given cubics which are factorized, so they'll look like x minus 3, x plus 2, x plus 5. So what you got to do is to plot these, all you need to know is that if I multiplied all these x's together, I would get a positive x cubed, and that is essentially how the cubic finishes. It finishes on the up, positive. So positives finish up, negatives they finish down. So I'll try and do 2. And essentially anytime, so if x was equal to 0, then this bracket would cancel out the other two brackets. because 0 times anything is just 0. So that's a solution at x equals 3 is a point where the cubic crosses the x-axis. So y equals 0, x equals 3. And then another solution is x equals minus 2. So we're going to get one here, and minus 5. Now your cubic could either go this way or it could go this way. Those are the two options, but the way to know is if you multiplied all your x terms together, would they be a positive x cubed or a negative x cubed? If it's a positive x cubed, positives finish up, negatives finish down. So the other point that you can work out is where it crosses the y-axis, and to do that you want to sub in x equals 0. I don't know if this one's going to cross in a nice spot, but basically if x equals 0, then y is going to equal 0 minus 3, 0 plus 2, and 0 plus 5. So essentially I've subbed in x equals 0 wherever there's an x in the equation, which has just left us with minus 3 times positive 2, which is minus 6, times positive 5. So this is actually going to go off the graph a bit, and cubics are like that. At negative 30, that's where the graph would cross and come back and go down. So it finishes positive. This is a positive finish. So with a cubic, when you're drawing it, you only need to get a couple of points. You can just where the 3 x-intercepts and the y-intercept, and it's heading positive. If I see all those three things, then I'll give you the mark. It doesn't have to look pretty. But yeah, what I'll do now, I want to just show you these graphs on Desmos. So I'm going to just have a play around with Desmos for you guys. Alright, so a good place to start with Desmos is just if you just type in the formulas that you've learned, and you just put a variable where there would usually, so that would be xc in the circle formula. Then we go y minus b squared. Also, that's something to note. Sometimes it can be a bit hard to. I'll just get the draw cam. So if you do shift 6, then you're going to get. That's how you get powers on a laptop. Sometimes it's not very obvious how to do that. Let's get back to here. So we want that to equal a radius squared. So let's just experiment and do the one I did before, which was x is minus 3. R is 2, and B is 5. So there we have it. You can see that the center of the circle is at 3, 5. So it corresponds to these points, and the radius is 2. So if you change any of these numbers, you can make this 5. The center of the circle is still at 3, 3, 5. You could change these numbers, and you've got 7. Whoops. That's just bumped it up. If I made this a plus, what's going to happen? It's going to flip to the other side. So now the center is at -3, +7. So it's always the opposite to what, well, because yeah, honestly, I would just do that. But yeah, it's good to, those ones where it just gives you the equation is kind of basic, because you've got, you can just put it into Desmos. But if you're going the other way and you were given, say, this picture, you've got to be able to work your way backwards. So you've got to be able to go forwards as well as backwards. So just make sure you understand how to do both ways, if that makes sense. Yeah, so that's circles. We'll just leave that as 9. So that's a nice, well, 3. Okay, so now it's at -1. But yeah, I mean, you can do this with Desmos with any formula. If you just go y equals mx plus c, then you can add sliders for a and for m and c, and see, by changing the gradient, I've essentially, you can see what's happening there. So Desmos is a great tool because you can just straight up copy the formula for a general thing in and create these sliders, and that can give you the idea of how things work. So, or you can and just play around. Okay, yep, see, that's moving my y-intercept. It's at 4, so it's at 4. Yeah, but you can do that with any formula. So let's go for that that cubic, see how that looks out. -2, oh, was it -3, x plus 2, x minus 5. Yeah, so it's a handy thing for Desmos is shift. Yeah, if you hold shift, you can squeeze an axis. So what I'm doing now, I'm holding shift and I'm just hovering over the axis and rolling my scroll on my mouse, and that just allows me to squeeze the y-axis, which is really handy with the cubics because generally they get really massive in the y direction, because I mean you're multiplying x by itself 3 times over. So yeah, well, you can see that was where I predicted the y-intercept would go through it at -30, and that's because if you had x equals 0 here, here, and here, then you're essentially just multiplying -3, +2, and +5 together. makes negative 30. Also, one way that things end up being negative is if, say, these were around the other way. So if we had 3 minus x, then for this bracket to be 0, x needs to be 3. So we're still here. So we've still got the same intercepts, but it's just flipped up the other way. And that's because if you multiplied this whole thing out and you had a big, long, expanded cubic, then you'd have a negative x times a positive x times a positive x makes a negative x. But if I did that to 2, then I'd have 2 negatives. Oh wait. So 2 negative x's add together to make a positive. So you got your graph is finishing positive. Yeah. All right. I might stop there. Type any sort of questions that you want me to go over. Do you want me to do any more detail into circles or cubics? Yeah. What have we got? I've got the actual assignment up, so you can have a look at that. Alright, so it starts off, it's got a circle, simple circle, then B is a circle, C is a cubic, D. Now D's an interesting one actually, because I'll give you the but yes, you can essentially, this is 1D, so this is an interesting cubic because we've got this part. Well, actually, I don't even need to include that too. So we've got x minus 1 twice. So this would be the same as writing x minus 1 in a bracket. So whenever you get a double up, it's like you've dropped a parabola on the line. Similar to if I had this is similar to like if I just did x minus 1 x minus 1, oops, we'll make it a steep one, 5. So when you get parabolas that have double ups, so this is essentially the same as that's interesting that it also goes through that same point with this equation in a bracket. Didn't know if that would do that, but so if that's squared, then it's like putting a parabola on the line at x equals 1. Yeah, so essentially you can do the same here with that equation. What's going on? Oh, right, that's because I've stretched the axis. You can see how that circle has become an ellipse. Alright, so that was, I've basically shown you 1D, but I mean you can all... Yeah, I can do that, Helen. So Helen just asked if I could go over the quadratic equation for the circle. So I might just invent a new problem just to start us from the start, but basically the same. So well, actually I'll draw a circle in Desmos. So let's use this one that we've already got. So this equation here, I'm just going to write this into my book. X plus 1 squared plus y plus 4 squared equals 9. Alright, so let's try and find something like this on the circle. Oh, maybe that's probably a bit easy. Let's go if x is 1. Let's say x is 1. We want to know what's out here. Okay. So I'll just do this with the overhead thing. So we do. Sometimes Desmos is too easy, so we need to just do it with pen and paper. All right. So this is our formula, and we want to know the coordinates. What coordinates of the circle are intersected by a vertical line at x equals 1. Okay, so first thing first, we want to just put that into our equation. So we're going to get 1 plus 1 squared equals y plus 4 squared equals 9. So expanding this out, we're going to get 2 squared, so this is going to become 4. I might just use my highlighter. So my first step was to put in x equals 1. I kind of rushed this. I'll make this more clear what I did here. So this is the same as y plus 4 times y plus 4, and that equals 9. So, or 3 squared. So our radius of our circle is 3, right? Okay, so we'll just leave everything else alone. We'll just deal with this quadratic. Y times y makes y squared. Y times 4 is 4y, and 4 times y is 4y, and 4 times 4 is 16, and that equals 9. So if you expand enough of these, you sort of work out the pattern. Basically, the middle term is double that, and then the end term is this squared. So, for example, I could do x minus 3 squared. If I wanted to just skip a few steps, I could go straight to x squared minus 6x, because I double this and I tag an x on the end, and then the last term is going to be positive 9, because 3 times negative 3 makes positive 9. So you don't really need that much working, but I wanted to show everything. Okay, now we've got a big equation that we can simplify to make it into a quadratic. So we want to put 4 and 16 together to make 20, and 20 minus 9 would be 11. So we're going to get y equals 8y plus 11. So that's just, that 11 came from moving these around and adding them together. And that equals 0. So just because we're dealing with y's doesn't mean that the quadratic formula is going to work any differently than it would for x's. It's still that sort of form, right? So we've still got our a out here is a is 1, our b equals 8, and our c equals 11. And I also skipped over what the quadratic formula is: minus b plus or minus b squared minus 4ac over 2a. So if we plug all these numbers into our quadratic formula, so we're going to get a y equals negative 8 plus or minus square root of 8 squared minus 4 times 1 times 11. So underneath the, and then divided by 2 times 1. Alright, so underneath the bracket we've got 64. 8 squared is 64 minus 44. So we're going to get square root of 20 in there. So y equals negative 8 plus or minus the square root of 20 over 2. 2 times 1 is 2. Oh, sorry, I just need to roll up a bit. Okay, so that's just a simplified quadratic formula, and that'll allow us to go straight to our numbers. So negative 8 plus, I generally like to put this top thing in with a bracket around it, because if I didn't, then when I chuck that in the calculator, the 2 is only going to divide the square root term and not the 8. You need the 2 to divide both this term and this term. So it helps to have a bracket there. Negative 8 plus square root 20. Oops, that's the problem with that. Divided by 2. Okay, so we get one answer is negative 1.764. And then if we go back and delete that plus and make it a minus, we're going to get negative 6.236. Okay, so those correspond to coordinates at 1, negative 6.236, and 1, negative 1.764. Oops, put up. Alright. Was that more clear, Helen? How was that? I'll just show you on the display. So let's just put in an equation. X equals 1. That's a handy thing to do on Desmos as well, is if you just put in x equals 1, it's going to that makes a vertical line, and if you did y equals 1, that make a horizontal line at 1, and that sort of makes it creates these intersection points, which you can hover over a lot easier than just like out here. It's not directly on the numbers, so yeah, there's that point and there's that point. Alright, that's all good. Yeah, I might just leave it with cubics and circles for this lesson. I don't want to introduce too much, but next time I think we'll do the exponential and maybe something else. What else is there on the the hyperbola? Yeah. So I'll just write down what. So question 1e is an exponential and f is a hyperbola. G also hyperbola. Yeah. Oh, a good thing, I might do this actually. I've got a good idea for a cubic question. So one thing that you might need to work out with cubics is because they're not always, they don't always have a shape factor of 1. So I'll just draw one that won't have a shape factor of 1. So I want it to go through here, here, and here. So I'm just going to force it to be really flat. So if it goes, so this piece of information here, that's going to determine our shape factor. So we can start off in the same way that we would do a vertex, not a vertex, a intercept parabola problem. So a general cubic is going to look like, we've got -3, -1, and +3. So our first bracket, well, actually, so there's going to be some shape factor that's going to push or pull the curvature of the cubic. So we don't know what that is, but we're going to use that point where it crosses the y-axis to determine that. So for this first one, we've got x -3. So that was for that intersection. And then we've got x +1, and then x +3. All right. And actually, this is a bit hard, isn't it? No, it's not. So to figure out what our shape factor A would be, we need to sub in something we know. We know y equals -1 when x equals 0. So we can sub that in. -1 equals a 0 - 3, 0 + 1, 0 + 3. So essentially -3 times 1 times 3 is going to be -9. Ugh, I hate -9s. They look like A's. Alright, so A is going to equal -1 divided by -9, or 1/9. Alright, now I'm going to just type, so actually before that, that is going to give us, our final formula, so we're going to get y equals 1/9 x -3, x +1, x +3. So there may be questions where you have to determine a shape factor of a cubic. So if I go into Desmos, I'll just change that over on your guys' end. Let's see how that formula turned out. Y equals 1/9. I'll just turn off a few of these actually. And x, oops. Oh, that's a plus, isn't it? Plus. Okay. And there we have it. That's the same as the one I drew. It goes through -3, -1, passes through this point 0, 1, and then goes back through 3. And finishes positive because if you multiplied out x times our x times our x, you're going to get a positive x squared. Yeah. Whew. All right. Anyone else have a question or suggestion? Nope. All right. I think I may end the stream there. That's a full 50 minutes. That's a full math lesson. So hopefully that helps a bit with getting through some of the assignment.